12.3 is geometric probabilities. We're going to start talking about some geometry involved with this probability here today. Before we get to that, we're going to talk about use a tree diagram to find the number of possible outcomes in each sample space. So tossing 2 pennies. So you tossed 1 penny, and that gives you either heads or tails. And then when you toss the second one, you get heads or tails, and you get heads or tails. That's a tree diagram to figure out what you have. So to find the number of possible outcomes in each sample space, you would have 1 with head, 1 with head tail, 1 with tail head, 1 with tail tail. So you have 4 possible outcomes. We can also use our fundamental counting principle there, 2 times 2. Tossing a penny, so you have 2 chances for that. And tossing a die, again, we're going to assume a normal die, so that would be 6 chances. So you would have 12 total possible outcomes that are happening there. If you toss 2 pennies and a die, then when you toss the 2 pennies, you have 4 possible outcomes, and the die, you have 6 possible outcomes. So the 4 comes from that first one that's there, and you end up with 24 possible outcomes there when you multiply those. Spinning spinner 1. So spinner 1, you have 4 possible outcomes, and tossing a penny. So tossing a penny, you have 2 possible outcomes. That would give you 8 total possible outcomes when you multiply those. Spinning spinner 1 has 4 possible outcomes, and spinner 2 has 2. So that also gives us a total of 8. Okay, tossing a penny has 2, rolling a die has 6, and spinning spinner 1 has 4. So you do 2 times 6 is 12, times 4 is 48 possible outcomes there. Okay, get into the geometries here. We're going to have probability of length and probability of area. So find the, probability that involves a geometric measure such as length or area is called geometric probability. Pretty simple there. If a line segment 1 contains another line segment 2, and a point on line segment 1 is chosen at random, then the probability that the point is on line segment 2 is the length of segment 2 divided by the length of segment 1. So what we're talking about here, if a point E is on AD, so you know E lands somewhere on AD, is chosen at random, then what's the probability that E is on BC? So that's going to be the length of BC divided by the length of AD. Okay, when determining geometric probabilities, we assume that the object lands within the target area. These are big assumptions. Within the target area, and it is equally likely the object will land anywhere in that region. Okay, so we're going to make some assumptions there. Okay, so our check here, we're going to choose a point at random on WZ, so on this whole segment that's here, and we're trying to find the probability to the nearest percent that A is not on YZ. Okay, so it says, what's the length of YZ? So 6 plus 5 is 11, plus 3 is 14. Sorry, that says WZ. I can read. And then what is the length of YZ? So YZ is 3 units long. To the nearest percent, what's the probability of A is not on YZ? So you can do a few things. Not on YZ would be 11 out of the 14, or you can do 1 minus the 3 out of 14. You will get the same thing out of either one of those. And if you do that and get a percent, you'll end up rounding it to 79%. So it's to the nearest percent. So no decimals there. So 79% is what you should get there. So geometric with area, it's same idea. Is that if region A contains if region A contains a region B, so you see region A that also contains B. So A is the entire thing, the whole box. It's not with B removed. And a point E is in region A. So we know that E lands somewhere in region A. And A is chosen at random. Then the probability that E is in region B is area of region B divided by area of region A. So you would do the area of the circle divided by the area of the square that's there, okay, or rectangle. Okay, so assumptions. When determining the probability that a toss will land on the target, we are assuming that the toss must land on the game board. So it must land on, and not on the ground surrounding the game board. Okay, so understanding that if I took a box and was throwing a penny into it, the penny didn't go in and then jump back out. Okay, it lands in that box. Notice that the diameter of the target is given in inches while the diameter of the game board is given in feet. When finding probabilities, be sure to check that all measurements are in the same unit. Okay, otherwise you will have a miscalculation there. And that is that. So you have your homework to do from this section.